Hi, I'm Shaili Sharkar of IM Computer Science and Engineering Department. Our final year project is Mixed Reality Window Manager. Before delving into our project, let us first try to understand how the human-computer interaction has been affected by previous generation of computing interfaces. The first one is the hardware switches. Well, what was the problem with the switches that made them almost obsolete? There are limited options and it's not possible to extend them. For example, Altair. The second one is the command line. Command line are very versatile in implementation, but the user has to memorize every other command. Hence, the work is multiplied. And last but not the least are the 2D and partly 3D graphical user interface. This is extensible and the user can even see the commands on screen and hence there is no need to memorize them. But the workspace unfortunately is limited to only the hardware screen. Where do we go from here? The future, where we have voice control, neural interface and mixed reality. Now my friend Shonak will explain to you about mixed reality.
Go. Thank you, Shaili. Now let's talk about mixed reality. The line that you see right now is the reality-virtuality continuum. Reality is the world we see around us, while virtuality refers to the computer-generated environments. Augmented reality is extending the real world using virtual entities. Virtual reality is a computer-generated 3D environment where users can interact with virtual entities as if they were real. Augmented and virtual reality together combined forms the mixed reality continuum. This is where the border between reality and virtuality fades. Coming to desktop environments, it is a collection of programs that provide a graphical user interface, enabling its users to operate the computer. Here are a couple of examples of mixed reality desktop environments. On the left, you can see Safe Space, a virtual reality window manager. And on the right is Windows Mixed Reality operating system. So what is Arnolens? Arnolens is the code name for a mixed reality window manager for X server that we have made. What is X server? X server is a graphical user interface used by Linux and Mac for displaying their windows. Every application presents itself in the form of a window on the screen that the user can interact with using a mouse, keyboard or touch. Ordinary window managers render application windows on a 2D canvas, providing occasional 3D effects. However, Arnolens can render these windows inside a 3D virtual world. Why mixed reality? It is portable. This platform is designed for portable devices like head-mounted displays. These devices will be further miniaturized in the near future to the size of a contact lens. It is natural. You can interact with virtual entities as if they were real-world objects. It is unlimited. Forget the limitations of hardware screens because the space in the world of mixed reality is seemingly unlimited. This changes how we learn, work and play. It makes learning more fun, improves the productivity of a person and also makes leisure a lot more fun. So why is our system of mixed reality better? It is because of these following features, starting with X Server, one of the oldest and the best windowing system still in use in Linux and Mac. Since it is open source, that means it is always evolving. Arnolens supports any and every GUI application and it can run on any platform that has X server. Therefore, Arnolens is truly universal. Arnolens is also modular, which means every functional component of the system is replaceable. In the future, we also plan to support 3D native applications in Arnolens. with the help of a special 3D API. This API can help applications draw 3D geometry to create more intuitive virtual objects with more natural form of data presentation and input. Now my friend Shubhodip will explain how the system works.
Continuing with what Shona just said, let's focus our attention on these three elements because these three elements are very important for our system to function. Applications which need to render their interface connect to the X server and are called X clients. Platform refers to the OS, and that these functionalities are being safely carried out with the help of the OS. The server can render windows without the presence of a window manager, but it is very difficult to use such an interface. Window managers make this very easy by providing a way to drag windows on screen besides other functionalities. Window managers make an agreement with the X server to hand over the window controls to the window manager and let it handle windows on its own. A compositing manager connects to the window manager to provide additional visual enhancements. These greatly improve the look and feel and also the usability, providing features like peak, multitasking overview, transparency, shadows, blur effects, etc. They are also combined to form a compositing window manager. This is a special case. There can be multiple compositing managers which utilize the X-Render Composite extension. One example is Compiz, which provides a ton of cool effects aside from the ones provided by the stock compositor. Another example is Arnolens. Arnolens is capable of running on top of another compositing manager in a way that provides a fluid mixed reality experience to the already available compositor. We're using Unreal Engine 4 as the rendering engine for this compositor. The algorithm it uses for rendering windows is simple. Read from a list of windows provided by the window manager. If a window is already present, update its texture, else create a new window. If a window disappears from the list, then destroy its 3D counterpart. The compositor allows for basic window controls like dragging, resizing, and snapping. It also provides an entire virtual world as you see here, where I can peacefully work. This world is only visible when the compositor runs in VR mode or debug rendering mode. In AR mode, or rather augmented reality mode, this world is replaced by your own actual surroundings. The compositor supports physics simulation, advanced light rendering, and also partial environment reconstruction on using devices like Kinect, Intel RealSense, and Leap Motion. The window manager connects with the X server and can get info about all the windows that are currently mapped in the display. It also uses the composite extension to receive window visuals and then send them to the mixed reality compositor. These two programs use Unix shared memory and typical sockets for communication. Due to the composite extension, the image that it generates supports 1-bit transparency, which the compositor renders gracefully. The syncer class takes care of synchronization via sockets to perform a semaphore-like concurrent program execution over a single shared memory space. The compositor can also send a quit signal to the window manager, which causes both programs to exit gracefully using a handshaking method. When a session is registered using these two programs, then exiting these programs will cause Linux to log out. Now Deborshi will explain how input from the 3D world is being sent to the 2D windows in the X server.
Thanks, Shubhodip. Now let's get to where and how the actual interaction with the windows in Arnolens reflects onto the real apps running in the background. When an application starts running, it shows up as a 3D window in Arnolens. A set of relative pointer coordinates are calculated depending on the world space location of the 3D pointer. These are utilized when a click action is performed anywhere in the window. Depending on the width and height of a 3D window, a ratio is calculated, which is used for clicking on the real window. Firefox is starting now. Here it is. Resuming my last session. And play.
Jarvis, you there?
Oh, the window handling
Page
smoothly.
heads-up display.
Check.
Four-door preferences from home interface.
Will do.
That's fun. Oh, physics. Let's put it up on this wall.
All right, what do you say?
I have indeed
Let's try scaling it.
ready.
We start the virtual walk around.
This.
Importing preferences.
Ah, this
and
looks
calibrating
good.
Virtual environment.
And perfect.
Check on control surfaces.
As you wish.
What to do now? Let's try opening another window. There's the terminal. And it's up and running. Oh, collision.
Test complete.
Oh, slow down,
Power
slow down.
and begin diagnostics.
Yeah. tell you
let's
what,
run some
weather
updates.
needs to check. Start listening in on ground
Okay.
control.
Sir, there are still terabytes of calculations needed before an actual flight is achieved.
Jarvis,
Sudo app
sometimes you gotta run before you can walk. Ready?
Password.
And 3,
and
2,
connecting.
1.
And it's running. Oh, looks good. Sounds great with this video actually. I guess it's about to be finished and it's done. Let's quit. Oh, no. Exit. And the window is closed.
Overall, the software will help the people get easy access to the world of mixed reality and experience it the best. Utilizing the power of Arnolens, it will make this experience a very fun, exciting, easy and fluid one.